Hello, and welcome to another episode of Learning by Doing in Python Pandas, where you get to watch a real data scientist go through some Pandas exercises, look at some data, do some data science, at least a little bit, and basically see what goes through my mind when I do it, so it will help you guys the next time you are doing it. So, without further ado, I always kind of like skim through these guys the first time I look at them just to make sure there's nothing here that's crazy out of expected. This one's probably going to be a long one. It looks pretty complicated. So let's just jump right in. So today we're doing something on wind statistics. So they talk about the data. It's been modified to contain some missing values identified by NAND. So using Pandas should make this easier, in particular for the bonus. Oh, there's a bonus question. Great. You should be able to perform all these operations with a for loop without using a for loop. Exactly. Yeah, so this is great. Anytime you're using a for loop in Pandas, just think to yourself that you're probably doing it wrong. So anyways, so let's import the libraries. So if I were actually doing this as a real data scientist, I would totally go ahead and learn a little bit more about this data. But since not, I can kind of see like first 2 columns are year, month, day. Okay, the remaining 12 columns are average wind speeds in knots. Okay, cool. Okay, cool. So that's about all I'll need to know. The data is located here. Again, good to see this. Looks like it's tab separated, which is great. So let's go ahead and throw this into here. So our URL can go ahead and be this. So pd.readcsv. And again, reading CSV is great because you can read it actually from a URL. And remember, in this case, we need the separator to be a tab. So \tab. So this will give us a nice data frame. Let's just go ahead and check, make sure this looks good. No, it did not. It wasn't tab separated. It was, what is this? Is this space separated? It's not. What is the separation here? Let's check out this data set one more time. Just to make sure. Is it? It looks tab separated, doesn't it? Okay, let's just check. If the separator is not, well, let's go ahead and read a little bit about the data set. Just to, don't want that. It's following format. So if it's not tab separated, it's not going to be space separated. We already did that because you'll see here there's a ton of unnamed columns. Because down here as well. Yeah. Okay. A little bit funky. Let's see. Tab separation, space separation didn't work. Let's go ahead and check out the read CSV. See if it's got anything that it thinks can help us. File, header, infer. Okay. Let's go ahead and just throw this here. This is a very long function with a lot of funky stuff here. Let's see. File path, separator. If separator is none, so let's go ahead and just try to force it to auto detect the separator. Yeah, I was unable to auto detect it. Because separator defaults to none. No. Separator, let's check. So separator defaults to CSV. Okay, so let's go ahead and make the sep equal to none. Let's go ahead and, okay, trace back. What did it say? I could not determine delimiter. Yes, of course it couldn't determine the delimiter. We're trying to determine the delimiter. Okay. Use if none, see it will automatically detect. The latter will use. Be interpreted as alias for separator. Interesting. So maybe there is sort of like a little like regex type white space thing. Addition separator is only the one character and different from. Put it as regular expressions, and will force the use. Are prone to ignoring quoted data. Okay. Let's try this out. Maybe this \s plus will help us out. Otherwise, we'll just need to look up the regex for what just white space would be. \s plus. Okay, so that's probably, s plus is probably just sort of like white space delimited. Okay, so this is what our data looks like. So some nans, lots of numbers. One of the things that we can always do, df.info. This is always super good. So you can tell us kind of where the nans are, what we're dealing with, ints and floats and stuff like that. Okay, great. Looks like in the year, month, day category, these are all filled in. Otherwise, in every other category except for this BR, we have some missing data. Okay. Assign it to a variable called data and replace the first 3 columns by a proper datetime index. Great. So again, this is a lot of this is well, data. Great. A lot of this is going to be a little bit not new to me, but just I don't do a lot of time series stuff, so you're going to enjoy watching me fumble a little bit. So let's get started. So data. So the thing to use here is pd.toDatetime. Arg. So let's see. Integers, tuple, series. So integer, float, string, datetime, list, tuple, 1D array, series. Okay. So what we need to first do is if we check out our data here, we've got year, month, day. So we need to combine all of these 3 into one column. So we just can, so we'll need to make them strings and then we'll need to concatenate them. Is probably what we can do. We can also just, yeah, let's make them strings and make them concatenate them. So df dot, and we want to call this date, date string can be, now let's just go ahead and make sure df dot year, what is it called, yr, plus, so okay, we need to go ahead and make this, can I get an actual toString, as type, str, let's go ahead and just, a little plus here, and then let's go ahead and grab mo. Okay, so that looks good. So we're basically just combining these guys as strings. I don't think that, well, I don't know if we can actually do a dot format type thing, df dot format. That would kind of be cool to go ahead and make like a format string type thing, but this will be fine. So we'll actually go ahead and see in their solutions if they've got sort of a better, let's not do that, let's call it for, let's just make it a dash, if they've got a better solution as to this. So we'll do that, and then we'll just have one more plus, and instead of mo, this can be, what is it called, dy. Great. And this will go ahead and we'll assign this to datetime string. Great. And we can check this out, what the datetime string looks like. And it just kind of looks like year, month, day. Cool. So let's go ahead and do pd.toDatetime. The arg can be this guy right here. And then what we need to do is we need to get the format equals, and this is where the fun comes in as we try to remember what the format is. So maybe %y dash % m dash % day, maybe, who knows. 2061. Right. Right. I think I'd seen this. Year 2061. Do we really have data from that year? Probably not. Okay. Doesn't look that bad. So let's go ahead and save this. And then just make sure that this is exactly what we get. So let's call this pd.df.date. And then let's just check out df.head, make sure the dates look correct. 61, 101, 101, 61, 61, 101, 02. Great. Okay, great. And let's check the tail as well, just to make sure. 78, 1978, 1231, 1231. Great. Okay, year 2061. Do we really have data for that year? Create a function to fix it and apply it. Okay, this is kind of interesting. This is all 1961, most likely, right? Is that even true? Let's look at the... right, there's a couple of ways to go ahead and do this. So the max year is 78. One thing that we can do here, which is kind of like the lazy man's approach, is that even back here, we can go ahead and we can just sort of specify. So this is a 19 plus this, which will go ahead and make the date string a little bit nicer. And then the date, we can go ahead and instead of formatting it as lowercase year, we can format it as uppercase year. I believe this will be right, though don't quote me. df.head, 1961, great. Okay, so that worked. There's a question on what they wanted us to do here, but we'll go ahead and see. So we went ahead, we've got the date time, looks good. Great. Okay. Set the right dates as the index. Pay attention at the data type. It should be date time. So let's just make sure that the date time is in nanoseconds. df.date.dtype. Cool. Yep, it is in nanoseconds. Perfect. And then let's go ahead and just set this as the index. df.setIndex. And let's go ahead and call this. What is this? Just take a string. Great. Date. And then we will call this in, well, let's just check to make sure. Great, okay. And we will go ahead and do this in place equals true. Perfecto. Okay, and you can go ahead and check this out. So we've got this there. Another thing that you can do is you can drop this as well. So, but anyways, as in drop the year, month, day, as well as the date string, but we'll keep it for the moment. Okay. Compute how many values are missing for each location over the entire record. Okay. Ross. Okay, so these are locations, I guess. 12 locations in Ireland on that day. Average wind speed. Okay, great. And so, the easy way to do this, as we sort of saw, was you can just do df.info. And this will show you the number of things that are missing. So, pretty simple. The other thing that you can do here, if we want to be like really cool, is we can do df dot what is it? Is a name dot sum. So this will go ahead and give us each column how many NAs do we have. So we've got a couple of them that are full, like Bell and Burr. Compute how many non-missing values there are in total. Okay. So this is super simple. Is NA. And then what we can do here is -1. And then we can just sum this. Yeah. So this will give us, well, how many non-missing values there are in total. It's kind of like a funky question. So does it, I'm going to assume that it basically means how many data points do we have, not how many data points do we have, because obviously some of these are full and in that case it would just be 5,000 or 6,574. I assume that it means from the RPT to BEL or to MAL, how many of these are not missing. So let's go ahead and let's get that. So df.lock. This way we can go all the way from RPT to MAL. Okay, cool. So this will just give us the data, and then we can go ahead and do is NA, and then we can go ahead and do so this will give us how many things were NA, and then let's go ahead and do equals false. So this will be the number of things that weren't NA, and then we will go ahead and do dot sum, and let's start with this dot sum. I believe there's like an easier way to do. I think you can do this dot sum in just one single move, but I don't have autocomplete when you go ahead and do these parentheses things, so just ignoring it here. So it looks to be 78,000, just data points, like just numbers to be specific. Calculate the mean wind speeds of the wind speeds. Calculate the mean wind speeds of the wind speeds over all the locations and at all the time. A single number for the entire data set. Great. So it's going to be pretty similar to this in truth. So let's get, for each location, let's take the mean wind speed over time, and then take the mean for each location. So this will be calculate the mean wind speeds. So for each location, what's the mean wind speed? And then overall time. And then what's the average per location? Now it's a little bit important that we do this just because in this way, because these guys do have missing data points. And so it does, there's a little bit of a meaningful difference by taking the mean per location and then per time. So for example, let's go ahead and get let's call this above let's just call this raw data. So if we do raw data dot mean, there's an axis here. Returns the mean of the values for the specific axis. Let's see if does this give us any, yeah, right? So the axis can be columns or not. So again, skip NA will exclude the null values. Axis levels numeric only. Okay, cool. So let's just go ahead and do this. Yeah, okay. So let's just do this for the silly thing, because I not really worked this out in my head whether having, of course, doing if the data were all there, doing mean over the columns and then mean over the axes, it wouldn't make a difference. But if the data is not all there, I'm just kind of curious. So let's go start with 0 and then do mean 1. Right? Can we even do that? Okay. Okay. So great. And then let's start with the other side. So mean 1, 10.2. So notice there is a difference here. There's right, and this is because of the way it kind of treats NAs. So if we go ahead and anyways, this is not really important here. Little bit of a weird thing, but just so you know, if you do have missing data, just be a little bit careful with it. Okay, so we went ahead and we did that. I wonder which way they will do it. Okay. Create a data frame called the lock stats and calculate the min, max, and mean wind speeds and standard deviations of the wind speeds at each location over all the days. Yeah, super simple. So we can just take the rd.describe. So it's basically just saying like, hey, check this guy out. So this is all of these things, mean, max, standard deviation of all of these places each day or over all the days. So pretty simple. Okay, describe is a really cool command. a data frame called day stats and calculate the min, max wind speed and standard deviation for the wind speeds of all locations that day. Okay, cool. So here, let's see if we can actually do this. So rt.describe, does it have an axis? It doesn't have an axis. So, maybe just the simple thing to do is take the transpose and then describe. Oh, dear Lord. What have I done? Oh, what have I done? Oh God. Man, that took a really long time. The transpose for each day. Okay, let's do .lock to just get the first 10, .ilock to just get the first 10 days, just to make sure. So we'll get the first 10. I guess we could have just used head. So .head to give us the first 10 days. .transpose describe. Okay. Yeah, and so this will give us the mean, medians, count, all these things per day, which is kind of cool. If we did the full thing, it would just take a little bit longer because it has to calculate all of these each day, but we could totally do it. Find the average wind speed in January for each location. Treat January 1961 and January 1962 both as January. Okay, cool. So let's go ahead and sort of see what happens here. df January. Yeah, okay. I knew that would happen. So we want to find all of the Januaries. There's probably a better way to do this. But for me, I mean, the easy thing to do, this is just so easy, is df.mo equals 1, so that's all the Januaries. And let's grab the df. Cool. So this will just be all the Januaries, and then let's do our little .lock thing so we can just grab the locations. So this will be the locations, and then we do average, so mean. So this will be the average on Januaries for each location. So, okay, cool. I'm kind of curious what they actually did here. Downsample the record to a yearly frequency for each location. Great. So this can be a df.resample. This is a really useful one, but it is a little bit tricky. Okay, so we resample to mean, and then we go ahead. Okay, cool. So, okay, so we're doing the resample stuff. The resample is kind of a little bit of a funky function, so let's dive into it. So it does this kind of rule thing, and the rule thing is, in this case, it's like, if you want to resample monthly, I believe yearly is A for annual, not 100% sure, and then how, maybe we can just do mean for the how, maybe the how defaults to mean. Does that default to mean for downsampling? Okay. Let's see what happens if we do that. Right. Right. And this is a downsampled thing. So ds dot. Yeah, I guess you downsample for each location. I guess we can do dot mean. Okay. Yeah. So there you go. Yeah, it looks like we actually did it annually. So 61, 62, 63, all the way up to 78. Okay, cool. So that's one way you can do it. It's kind of like a group by on a time basis that can be a little bit more sophisticated. So, okay, so it's downsample monthly, right? And I guess if we just provide a how here, oh, dear Lord, why is this here? Okay, great. So if we do how equals mean, I think it will just the new. Okay, fine. Fine. Okay. So we do ds.mean. Looks like I did it right the first time. Oh, so that's year, so let's do month. Yep, so that's month. Okay, monthly frequency. Dan sample to a weekly frequency. You know what we're doing. We're just going to try to do weekly with this. So ds.mean. That looks to be weekly. Yes, we did it. Calculate the max, or min, max, and mean wind speeds, standard deviations across all locations for each week. Assume the first week starts on January 2nd. Oh, interesting. So this would be really simple if we didn't assume that the first week starts on January 2nd. We do weekly and then we do describe. Oh, Lord. Oh, there's no describe. Whoa. Oh, okay, well, it's like, for me, it would almost be simpler to make this a group by question, where I take, each month, year, and then I concatenate that to, like a day, but set the days to just be like, make all the days either like a Friday, like either 1 or 0, where it's 1 is Monday and 0 is, so to just go ahead and do it that way. So let's go ahead and try to figure this out. So there's no describe. So what we can do, it looks like, is we can do ag, right? Right. So let's do that, and let's do ds.ag. So we can do ag. I'm so surprised there's no describe. There's no describe. So we can do ag, which can give us the, what is this? The min, max, the mean, and the standard deviation. Okay, so this does give us the min, max, standard deviation for all of these things for each week. So we just need to make sure it starts at the correct time. And maybe this is in the resample. Offset. Okay, that looks good. L offset looks really good as a parameter here. Adjust the resampled. So time delta. Okay. Okay. Let's try this. Let's try L offset. Let's just try it out. So let's go ahead and do ds.mean down here so that we can see what's happening. Let's do L offset. Let's just try 1. See if that does anything. Well, that definitely is weird. Oh, that's still there? Oh, did I change df? Let's just make sure that df looks okay. Hey, df looks fine. Well, why is this giving me something different? ds.mean. Oh, I said df.mean. Yep. So just always be a little careful here. Okay. So that's good. And then let's go ahead and do L offset equals 1. Let's go ahead. So that didn't do it. That didn't do anything. PD dot date time dot diff. So yeah, let's look at this one more time. So let's look at L offset. Takes a time data or a time delta. So I need to know how do I make a time delta? Oh God. Pandas. I I might have to Google time delta here. Time delta. Pandas. Okay, pd.time delta. Great. So let's go pd.time delta. Oh boy. Unit. Okay, it's a day. It's 1 day and value. So 1 and then 1 day. So this should be a 1 day time delta. Great, a 1 day time delta. Okay, let's go ahead and plug this into L-offset. Come on. Papa wants a brand new car. Yeah, okay, we started at January 2nd by using this time delta. So started January 2nd, 1961. Okay, so I hope you guys have enjoyed that. There was a little bit of sort of discovery at the same time. You can kind of see the way I sort of Google things and the way I look at things, inspect functions, a little bit of the intuition. So all that being said, let's totally go ahead and check out what the solutions to this are. Because I'm sure that especially for some of these, there are probably better solutions, especially that one where we did that group by, which I think was probably done by a resample. So some people get really comfortable with the Pandas datetime type of functionality, and we can get better at that. Importing datetime. Yep, there they go. They do the separator S+. Oh, look at this. They include a parse dates 0, 1, and 2 into this header. Okay, really cool. Great. Oh my god, that's super cool. I didn't even know you could do that with read CSV. Okay, great. 2061, fixed centuries. So they had to do this weird, funky thing where they go ahead and they change the century. Yuck. Okay, they changed the century. Totally fine. Set the right dates on the index. Okay, we did the date time. Set index. Perfect. We did that. Great. Is null sum. Perfect. Not so data dot not null. That's an even better one. Okay. Great. Yep. Calculate the mean over. So here's what they did. They filled NA values instead of ignoring them. So that's one thing that you can do. And they went ahead and they flattened. So this value is going to be different than both of our values that we got. As you can see, let's go up here. Excuse me. Keep going up. Oh boy. 228. Yeah, 223. So it's going to be different from all of ours just because they filled NA. You don't need to fill NA. You can ignore the NA. It really just depends on what you feel more comfortable with. I personally like ignoring the NA when calculating aggregate statistics. Describe. Oh, they went ahead and they knocked out the percentiles. Another really good one. Get a different set of numbers each day. Okay. Yep. They did this. I personally like doing the ag syntax here, but this is totally cool. Right. What did they do for the January one? Let's see. So no, they did this index. Okay, they did index month. Totally fine too. Just not 2 period. Okay, they did a group by. I think the resample is going to be better here, to be honest. I like the 2 period though. That's pretty cool. And they did 2 period mean. That's awesome. Really, really awesome. 2 period mean for the week. Perfect. They did an ag, which is great. Okay, and then what they did is they literally just sliced. So to be frank, I like some of the stuff that they did here. I personally like the way that we resampled better. I think that is a little bit more intuitive. And if you're working with time series, again, you'll want to use the resample instead of the group by, generally speaking. Sometimes it's just hard, like that find all Januaries. But sometimes you got to do what you got to do. So I hope this has been really good. If you liked it, leave a like and subscribe. There's going to be definitely more coming out from Data Talks. So I'll see y'all soon. Thanks.